Hello champions, welcome to the next lecture on the CSIR Net July 2025. Today I will explain you how you can solve the part C related questions of the linear algebra. Myself Dr. Harish Garg. You can follow and subscribe my YouTube channel where you can find the playlist of the CSIR UGC Net. In this playlist you can see I had uploaded all these solutions with the help of the shortcut tricks for you. You can watch and subscribe my YouTube channel for the future notifications. Now, this is the first question which is related to the part C and how you can solve them within a 10 to 15 second time periods. So firstly, I will tell you what is the concept behind this question. Your target is to find the linearly independence. Fine. So कैसे solve करेंगे आप? If I construct the matrix A and if I prove that the determinant is my non-zero, this implies the corresponding vectors or the corresponding functions are my Li. Is it okay? Now look at that. F is given to you. Can you calculate the f dash? This number is my 2x plus 1. Can you find the value of the f of x minus 1? So that number will be x minus 1 whole square. X minus 1 and 1 will be cancelled. If you open them, it is a x square minus x plus 1. Similarly, another one you need a f of x plus 1. If I substitute the value of the x plus 1, it will be x square plus 2 plus 1 is 3x plus 3. Fine. Now let's start with the first option. If you write the matrix f dash, so it's a 3 cross 3. This is my constant term. Fine. This is my coefficient of x. This is the coefficient of x square. So can you write the constant terms in the f dash? 1. Coefficient of x is 2. Coefficient of the x square is my 0. fx minus f of x minus 1. What is the value of the fx and f of x minus 1? Fx is my x square plus x plus 1. If you subtract them, that number will be my 2x. So that is a coefficient of x only. Rest are my 0. Then is a 1. 1 is my constant. The rest values are my 0. Fine. So can you find the determinant of this matrix? So clearly say 1, 0 minus 0 and plus 1 of 0 minus 0, which is 0. That means the vectors are my LD, but we need the Li. Similarly, for the second part, if you write the matrix corresponding to fx plus 1 minus fx, x square will be cancelled. It's a 2x plus 2. Constant is my 2. Coefficient of x is 2. X square is my 0. fx and fx minus 1, which is already computed 2, 0, 2. And 1, it's a 1, 0, 0. Can you find the determinant? So determinant is 2 is 0 minus 0 plus 1, 0 minus 0. Again, they are LD. So the second option is also cancelled. Now look at the third options. The value is fx. Let's start with the third option, fx. Fx constant, coefficient of x, coefficient of the x square. F dash 1, 2, 0. And the constant is 1, 0, 0. So how you can find the determinants? I think it's a very simple. You can find the determinants. It will be 1, then minus 1, and it's a plus 1. It's a 0 minus 2, which is my minus 2. It's non-zero. Yes, third option is the correct option. Look at the last one, f of x plus 1, constant, coefficient of x, x square. F of x minus 1, constant term, coefficient of x square, and fx 1, 1 and 1. So if you find the determinants, it's a minus 1 and minus 1, then it is a 3 minus 1 and plus 1 of 3 plus 1. So clearly say it's a minus of 6, it's my minus of 2, it's a 4 plus 4, which is my non-zero. So yes, it is also Li. Third and fourth, that's a C and D, are my right answer of the problem. Okay, look at this another one. Consider the field F3 consists of the 3 elements. So any field you may consider as a Z3, fine. But anyhow, V is a vector space of dimension 3. W is a vector space of dimension 2. So that means V to W, the dimension of this is my 3. Dimension of W is my 2 over the field F3. then the number of the two-dimensional subspace, number of the onto mappings, number of the one-dimensional, number of the linear transformations. So firstly, I will tell you if T is a transformations from V to W, fine, such that it's a F3. So if I write here is F of Q, three dimension, let's say N, to F of Q of M, then the number of the linear transformation is Q raised to power N into M. Fine. Now look at that. What is that given to you? V is a mapping, V is a vector space, F3 having the dimension 3 to F of 3 of 2. So can you find the number of the linear transformation? Q is my 3 raised to power 3 into 2. So the answer is 3 raised to power 6. Yes, the first option is the right answer. D option is the right answer. Now, how you can find the number of the onto mappings? Look at the second options. Your target is to find the number of the subjective, that is the onto map from V to W. So you can find as a number of, first of all, it's a onto. Fine. The matrix T must be of the M cross N. So in this case, whatever the linear transformation, it is of my 2 cross 2. Now once it will be the onto के लिए क्या होना चाहिए आपका rank of the matrix किसके बराबर होना चाहिए? Number dimensions of this value, that's a 2. Fine. यही होना चाहिए आपके पास. Now how you can find the number of the onto mappings? What is our domain? It's a Q raised to power N minus, remember this formula, minus Q of say I, and your answer will be the number of the onto mappings are product I varies from 0 to rank minus 1. Fine. Now in this case, what is the rank? Rank is 2. That means your answer is product of 0 to 1 Q of N, that is a domain, 3 raised to power 3 minus 3 raised to power I. So if you open them, it's a 27. When you substitute 0, it's a 1. 27 minus 3 raised to power 2 is a 9. So that give you 26 minus, what is that, 27? Sorry, 3 raised to power 1 is 3. Fine. 3 raised to power 1 is 3. So that's a 24. So that number will be 4, 2 and 6. 624. Yes is the right answer. Fine. Now look at the third options and the first options. They are talking about the number of the subspace of the V. What is the dimension of the V? 3. Your target is to find the two-dimensional subspace over the field F3. Fine. Now, what is the meaning? How you can write this formula? It's a very, very simple. That means the mapping, the subspace is my 2. So you have to write it as a 2 times. Fine. This is my option A. But if you look about the option third, they are talking about the one dimensional of the V. The dimension of the V is my 3 up to the 1 over the field F3. So because it is my 1, you have to write only as a 1 time. Right? Now how you can write that? This the dimension is 3. So 3 power 3, fine, minus 3 power 0 or 3 power 1 divided by 3 power 2 minus 1. Fine. Or the best way is that I can tell you, you can write this number 3 2 times with respect to the power. 3 raised to power 3 minus 1 and 1 minus 3 minus 2. Fine. Similarly for the denominator, 3 power 2 minus 1 and इसमें से एक पावर कम करते जाना आपको, 3 raised to power 1 minus 1. अगर आप इसको लिखोगे तो कैसे लिखा जाएगा? 3 power 3 minus 1 एक ही बार लिखना है divided by 3 power 1 minus 1. Now you can check whether it's a 13 or not. 27 minus 1 26, 9 minus 1 8, 9 minus 1 8, 3 minus 1 2. So that give you 13. Yes, the first option is the right answer. Look at this one, 27 minus 1 26, 3 minus 1 2, that is 13 is the right answer of the problem. So all are my correct answer of this problem. Fine. और बता दे रहा हूं आपको, if you have a suppose you have a vector space V having the dimension 4, then your target is to find the two-dimensional subspace. So that means over the field say f of 5. Then how you can write? You have to write the 4 as a 2 times 5 raised to power 4 minus 1. एक पावर कम कर दीजिए 5 raised to power 3 minus 1 डिवाइडेड बाय इसको भी 2 बार लिखिए 5 raised to power 2 minus 1 and 5 raised to power 5 raised to power 1 minus 1. Fine. So that is the way you can calculate the number of the two-dimensional, one-dimensional, three-dimensional and so on. उम्मीद करता हूँ वीडियो को लाइक और चैनल को सब्सक्राइब जरूर करेंगे. चलिए लुक एट दैट. दिस इज द पार्ट बी. फाइन, दिस इज द पार्ट बी. And if you look about that, this is a similar question about the field. The F5 consists of the 5 elements. How many matrix? So that means they are basically from the R2 to R2. Fine. तो इसके corresponding जो भी मैट्रिक्स बनाओगे उसका साइज क्या होगा? It is always be my 2 cross 2. Fine. Then your target is to find of the rank 1. So what is the meaning of the rank? अगर rank 1 है तो क्या वो कभी onto मैट्रिक्स होगी? कभी नहीं होगी. फाइन, बिकॉज ऑन टू होने के लिए आपको क्या चाहिए? नंबर ऑफ दी डायमेंशन इसके बराबर होना चाहिए. तो ऑन टू के लिए नहीं पूछा, लेकिन पिछले एग्जांपल में आपसे ऑन टू के लिए पूछा था. फाइन. चलिए, देन हाउ यू कैन फाइंड द नंबर ऑफ द मैट्रिक्स? इट्स अ वेरी सिंपल. आई कैन टेल यू. आप अदरवाइज दिस द पार्ट बी. You can watch my previous lecture of the part linear algebra part 2. The same solution I already uploaded in this video as well. But anyhow, I will tell you again. If you have the matrix M cross N is my any matrix and they are talking about the over the rank R. Fine. Over the rank R. Then how you can find the number of the such matrix? So you can write it as a product. I varies from 0 to R minus 1 into what is the field? Field is my f of q. So q raised to power number of the rows minus 1, q raised to power number of the columns minus 1 divided by q raised to power rank minus 1. That is the simple. Or instead of the 1, I can write it as q raised to power I, q raised to power I, q raised to power I. Fine. So if you compare them, what is the value of the m? M is my 2, n is also my 2. What is the rank? Rank is my 1. What is the field? Field is my 5. So if I substitute here r minus 1, so that's only the one term. 5 raised to power 2, 5 raised to power 0. Multiply 5 raised to power 2, 5 raised to power 0 divided by 5 raised to power rank minus 5 raised to power 0. 25 minus 1, 24. 25 minus 1, 24. 5 minus 1, 4. So that's a 6. 24, 144 is the right answer of the problem. Chaliye, look at this another one. A and B are the two cross 2 real matrix. अब जहां भी आपको मैट्रिक्स दिखाई दे जाए तो आपको किससे सॉल्व करना होता है? Either with the help of the rank or with the help of the आइगन वैल्यूज. यही तो मैं आपको अपनी हर वीडियोस में बताता हूं भी. फाइन. चलिए, इफ a is invertible then ba and ab have the same minimal polynomials. अगर a इन्वर्टिबल है तो कोई भी एक मैट्रिक्स ले सकते हो. a is equal to आइडेंटिटी. तो आप देखिए ये क्या बन जाएगा? b and b which have the same matrix. Anyhow, अगर किसी को भी सेम मिनिमल पॉलिनोमियल प्रूव करना है तो आप कैसे प्रूव कर सकते हो? अगर मैं ये प्रूव कर दूं कि मैट्रिक्स x इज सिमिलर टू द मैट्रिक्स y, then they have the similar minimal polynomials, they have the similar eigenvalues and so on. So now look at that. Matrix A is my invertible. So that means I can say A into A inverse is my I. So can I write here is A inverse A of BA? Fine. I can write also this number is AB of A. What is the meaning of that? BA is similar to the AB. Why? किसी भी दो X is similar to Y. That means X can be written as invertible matrix. Fine. तो यहाँ पे आपकी P है. The first option is the correct answer. Look at the second options. 0 is the eigenvalue of the A. So अगर if your A is my 2 cross 2, 0 is an eigenvalue of the A. So that means the rank of the A must be less than equal to 1. Fine. If 0 is the eigenvalue, that means the determinant is 0. So the rank must be less than 1. Then 0 is the eigenvalue of the AB. What about the B? B can have any value. So can you find the rank of the AB? Rank of the AB is always be less than equal to minimum of rank of A, rank of B. Now whatever the rank of the B, it may be 2, it may be 1, it may be 0. The rank will always be less than equal to 1. So once the rank of AB is less than equal to 1, what does it mean? That means the determinant of AB is my 0. That means 0 is the eigenvalue of AB. Fine. So second option is also the right answer. Look at the third option. 0 is the only eigenvalue of the A. Now the word is the only. 0 is the only eigenvalue. So if I choose this is my 0 is the only eigenvalue of the A, fine. And if I choose the matrix, fine. And 0 is also the only eigenvalue of the B. So if I choose the only eigenvalue, say this number, fine. Then 0 is also the eigenvalue of the AB. So is it true? So can you find the value of the AB? The first value will be 0. First column 0. This number will be my 0 and it is my 1. So can you find the eigenvalue of the AB? Eigenvalue of the AB is my 1. But he said 0 is the only eigenvalue. That's a wrong option. AB and BA have the same minimal polynomials. So इसका मैं BA भी निकाल देता हूँ. What is the BA? So if B is this one, so can you multiply them? First value will be 1. Second number is 0, 0 and 0. Now clearly say AB and BA. What is the minimal polynomial? Minimal polynomial is x into x minus 1. Both have the same minimal polynomial. Either A or B is invertible. But you can see neither A nor B is my invertible. So the right answer is A and B are the only right answer of the problem. Shall we look at the next one? C is a R vector space of real valued continuous functions. C is a real valued continuous function with the norm of this one. Fine. The norm दिया हुआ है आपको. Capital T is a mapping from this one. F is a map. F is a part of the C of 0, 1. So can you think about any of the continuous real valued function? Any constant functions, polynomial functions, exponential functions, sine, cosine and so on. यही होगा ना? So the easiest way I can choose the f is my constant function. Is it okay? Then T of n is the composition mapping. Which of the following statements are my true? So first option is we need a 2 mapping. If I choose f is my 1, g is my 0, then what is the value of the T of f? Fine. What is the value of the T of g? So T of f is my 1. If you substitute 1, integration from the 0 to 1 is x. If g is my 0, T of 0 is my 0. Then what is the value of the T of f? Minus T of 0. So that will be x minus 0. Fine. So that is my norm of x. And by the definition, it is a supremum over the closed interval 0, 1. Can you find the supremum of mod x when x belongs to the 0, 1? Fine. So that number will be my 1. So that means the left hand side is my 1. Right hand side will be alpha. F is my 1. G is my 0. So that number is my 1. So is it possible? Can you choose any value of the alpha which lies between 0 and 1 which satisfies this condition? No. So the first option is cancel out. Fine. Now look at the second option. There is a t square. So again, what is the value of the t square of f? That is a first of all t of t1. Fine. By using the composition mapping, what is the t of 1? T of 1 is my x. And if you substitute t of x here is, this is x square by 2. And what is the value of the t square of 0? T square of 0 is my t of 0. Fine. T of 0 is my 0. So that number is my 0. So therefore, you can calculate the norm of t square f minus t square g, that number will be my x square divided by 2 norm. So that will be give you supremum of x square divided by 2 from 0 to 1. So that number will give you half. Find the maximum value of the x square is occurring at the 1. So therefore, the second option said is a half, which is less than equal to alpha 1 minus 0. So can you choose the value of the alpha which lies between 0 and 1? Yes, of course, the alpha will be my half. So yes, the second option is the correct option. Or you can choose any other number like say 0.7, 0.8, which are lies between the 0 and 1. Look at the third option. The set collection of all those functions such that t of f is my f. Fine. So what is the t of f? X varies from integration of 0. Fine. Now can you solve this function? If I differentiate them, f is equal to f dash. So what is the solution? It is look like say y dash is equal to y. So the solution will be c e raised to power x. Now how you can find the value of the c? So let's start with the initial condition. What is the f of 0? You can see when x is 0, integration from 0 to 0 is my 0. So if I substitute the value here, e raised to power 0 is 1. That means c is equal to 0. Therefore, your function is my only 0 map. Fine. So that means the function f, the set c has, the set is only my 0. So that is the, yes, it's a singleton map is the correct option. Look at the last options, t of n. So as t of n, norm of the tn. Fine. So what is the value of the t? If I choose again, f is my 1 for all function. So t of 1 is 1 of x. T square will be, if I substitute x, integration of the 0 to x is x square by 2. Can you find that t cube? T cube, that is a x square by 2, that is a x cube divided by 6. So I can write as a 6 is my nothing but 3 factorial and so on. So the t of n is my x raised to power n over n factorial. Fine. Then your target is to find the norm of the tn. Once you can find the norm, that means your target is to find the supremum. So can you find the supremum of this? It's a 1 over n factorial, which goes to the 0 as n approaches infinity. But he said it's a infinity. So the right answers are B and C are the right answer of the problem. You can watch about my this playlist. You can watch about my this complete playlist so that you can understand its concept very simple manner. Chaliye, look at this another one. B is a non-degenerate symmetric bilinear form. So whatever the matrix you can form, the determinant is my non-zero for the non-degenerate. Once the determinant is non-zero, that means the eigenvalues may be positive, eigenvalues may be negative, or you can say the matrix is my indefinite. Fine. Then Q is my corresponding quadratic form such that of this case. So it's a R2. Fine. So it's a 2 cross 2 matrix. Fine. It's a V W V W. Now it is given that V and V are my 0. V and W are my non-zero. So let's say this number is my alpha. No, alpha is already given in the statement. So I can say this number is my X because it is a symmetric. Fine. So this number is also X, and whatever this number, it can be any number. Now look at the first part. This is my matrix. Now for the non-degenerate, determinant should be non-zero. So this implies V of this. If I consider this number is my Y, does it 0? No. It may or may not be 0. Whatever the value of the Y की कुछ भी value हो ना, determinant तभी non-zero ही आएगा because this number is my non-zero. That is X is my non-zero. The first option is my wrong option. Fine. Similarly, if you look for the fourth options, if you write the matrix corresponding to this x square, symmetric and -1. So clearly say that determinant of this matrix is my -1, which, or you can say this matrix is my indefinite because the eigenvalues are positive as well as negative. So yes, it is equivalent to the quadratic form. because it satisfied my non-degenerate form. Now look at the second options. Q of alpha v plus w is my 0. So can you find the value of the q? It is given that q is my v of v. That means alpha v plus w, alpha v plus w is my 0. Now you can open them. Make sure alpha belongs to the real number. The first part will be alpha square of v comma v plus, अगर ये complex number होता then it will be alpha into alpha complex conjugate. Second is alpha is outside, v of fine. Third is alpha again common, v of w comma v, and the last part is v of w comma w. Since this part is my 0, it is given. So that, and this is symmetric, so it's a double. So 2 of alpha v of w, which is equal to minus, fine. So can you find the value of the alpha? Alpha will be minus w comma w divided by twice of, because the denominator part is my non-zero, fine. Whenever the numerator is 0, again you will get the unique alpha. If the numerator is non-zero, then again you will get the unique alpha. Yes, there exists the alpha, but in the third option he said infinitely many alpha. That's a wrong option. B and D are the right answer of the problem. Okay, let capital S and T are the, so that means S and T are my 2 cross 2 matrix, and which of the following statements are my true? If I consider H is my ST minus TS, then again this is my 2 cross 2 matrix. Then clearly say the trace of the H will be my 0. Fine, because the trace of ST and trace of the TS is same. So what is the meaning of that? अगर आपके पास दो 2 क्रॉस 2 की मैट्रिक्स उसका ट्रेस 0 है तो उसकी वैल्यू क्या हो सकती है? इधर बोथ आर 0, whatever the values of this A and B, fine. और कोई वैल्यू हो सकती है आपकी. It may be the A, it is a minus of A, it can be any value, fine. Or is there any other way? It may be possible that it is a A, it is minus of A, it is B and it is C. यही होगा ना? Fine. Then your target is to find the square of the matrix. Okay, तो पहले यहाँ देख लेते हैं. ST and TS, that is H has only one eigenvalue. यहाँ तो 2 eigenvalue मिल रही है आपको, A and minus A. So only this case which involvement of the one eigenvalue. No. Okay, आप इसके रिस्पेक्ट में एक A और B की वैल्यू ले लेते हैं कुछ भी. इसकी एक ही eigenvalue मिलेगी, has only one eigenvalue. Then ST minus TS, that is basically H. Can you write this number is lambda of I? No. So the third option is the cancel option. If ST minus TS has only one eigenvalue, again ये केस में इसमें तो 2 eigenvalue है ना आपकी A और minus A, then इसका स्केयर क्या मिला आपको अभी? 0 1 0 0 0 1 0 0. If you multiply them 0 0 0 0, so that is a 0 matrix. Yes, this is the right option. Fine. चलिए अब देखते हैं फर्स्ट और सेकंड ऑप्शन पे. अब आपको स्केयर चाहिए. सो कैन यू फाइंड द स्केयर ऑफ द मैट्रिक्स? फाइन. अगर आप आइगन वैल्यूज ऑफ द लैम्डा एच निकाल लेते हैं, देन व्हाट इज आइगन वैल्यू ऑफ द एच स्केयर? इसका स्केयर हो जाएगा. व्हाट इज आइगन वैल्यूज ऑफ दिस मैट्रिक्स एच? पहले मैं इसके आइगन वैल्यूज से देख लेता हूं. इसकी आइगन वैल्यूज क्या क्या आएंगी? दिस इज प्लस माइनस रूट ए बी. फाइन. इसकी आइगन वैल्यूज ए एंड माइनस ए, और इसकी आइगन वैल्यूज आपकी ए स्क्वायर प्लस बी माइनस. फाइन. और आप डिटर्मिनेंट से भी निकाल सकते हो ना. माइनस ट्रेस इज 0 प्लस डिटर्मिनेंट माइनस ए स्क्वायर माइनस बी स्क्वायर इज 0. फाइन. तो अगर लैम्डा एच की आइगन वैल्यू ये है तो एच स्क्वायर की आइगन वैल्यूज कितनी हो जाएंगी आपकी? दैट इज ए बी 0 0. फाइन. अदरवाइज आप यू कैन मल्टीप्लाई देम एच स्क्वायर. इस केस में आपका क्या हो जाएगा? दैट इज ए स्क्वायर 0 0 ए स्क्वायर. और इस थर्ड केस में आपकी ए स्क्वायर प्लस बी सी 0 0 ए स्क्वायर प्लस बी सी. नाउ यू कैन क्लियरली से I can write the first value is AB of identity. अगर second case होगा I can write as a square of I and a square plus BC of I, and this AB, a square and a square plus BC are nothing but my eigens value. The first option is the correct answer. And once you can write this matrix, then the characteristics polynomial, because these are only the unique eigenvalues, find AB and AB or only a square, and that means yes, you can write this number is 2. So A, B and D are the right answer of the problem. Okay, which of the following matrix are similar? So what is the property of the two matrices are similar? That means their minimal polynomials are same. Fine. Their eigenvalues are same. Fine. Their trace are same. Their determinant is same, and so on. So firstly, we will see what is the trace or what is the eigen minimal polynomial of this matrix A. This is the block. Fine. So first of all, what is the trace of this matrix A? 0. Is it okay? Now you can check about of the options. Whoever the trace is not at 0, then that option will be cancelled out. So trace is 0, trace 0, trace 0, trace 0. Fine. Fine. Now, because this is the block, this is the block. So can you find, okay, if I say this number is my H1, this number is matrix is 0, this matrix is 0, this matrix is H1. So can you find this matrix is say my A? How you can find the minimal polynomial of the matrix A? That is basically LCM of minimal polynomial of the matrix H1, minimal polynomial of the matrix H2. And how you can find the characteristics polynomial? That is the product of the characteristics polynomial of the H1, characteristics polynomial of the H2. Can you find the minimal polynomial of this first block? Because the value is my, so x plus 1 whole square. Can you find the minimal polynomial of x minus 1 whole square? Can you find the LCM? What is the LCM of this? LCM is my same. Fine. So that is the minimal polynomial of, that is x square minus 1 whole square. Fine. This is the minimal polynomial of the matrix A. So first of all, you can see whether this is any block, not a block. This is a block. Fine. पर यहाँ पे जीरो नहीं बनाना आपका, हमें तो जीरो चाहिए, यहाँ ब्लॉक नहीं है. दिस इज द ब्लॉक. फाइन. तो इसकी मिनिमल पॉलिनोमियल निकाल लेते हैं. इस केस में मिनिमल पॉलिनोमियल ऑफ H1, मतलब इसकी मिनिमल पॉलिनोमियल कितनी आएगी? आइगन वैल्यूज आर प्लस माइनस 1. फाइन. सो मिनिमल पॉलिनोमियल्स आर x plus 1, x minus 1. सेकंड नीचे वाले ब्लॉक की, इट इज अगेन x plus 1, x minus 1. So if you take the LCM, then what is the minimal polynomial? LCM will be x plus 1, x minus 1. But यहाँ पे तो स्केयर आ रहा है. फाइन. सो द बोथ द मिनिमल पॉलिनोमियल्स आर नॉट सेम. अगर सेम नहीं है तो ये सिमिलर भी नहीं होगा. फाइन. नाउ इज इट ओके? चलिए अब फर्स्ट ऑप्शन पे देखते हैं. द डायगोनल एंट्रीज आर 0 एंड दिस इज द कंपेनियन मैट्रिक्स. फाइन. अगर कंपेनियन मैट्रिक्स है तो आप इसकी कैरेक्टरिस्टिक्स इक्वेशन डायरेक्टली लिख सकते हो. इट्स अ 4 क्रॉस 4. So I can write as a lambda 4 minus 0 lambda cube minus 2 lambda square minus 0 lambda minus 1 and minus minus plus 1. Fine. So ये कितना बन गया आपके पास? Lambda 4 minus 2 lambda square plus 1 is 0. That means lambda square minus 1 whole square is 0. So that is the characteristics polynomials are same. So yes, the first option is the correct option. ये भी companion matrix है. Fine. So again you can write this. It's a lambda 4 minus 0 minus plus 2 lambda square minus 0 minus 1, which is not same as of the given minimal polynomials matrix. So second option आपका cancel हो गया. Now look at the first options. Third option. How you can find the minimal polynomial of this matrix? Again is a block. Is it okay? अगर ये ब्लॉक है तो इसकी मिनिमल पोलिनोमियल कितनी होगी? That is my x plus 1, x minus 1. Minimal polynomial of the H2. x plus 1 x minus 1, but because यहाँ मैट्रिक्स जीरो नहीं है, then you can never write as the LCM of the h1 and h2. फाइन, चलिए अब मिनिमल पॉलिनोमियल से तो नहीं निकला, हम आइगन वैल्यू से निकाल लेते हैं. कैन यू फाइंड द आइगन वैल्यूज ऑफ दिस मैट्रिक्स? तो ये मैट्रिक्स कैसी बनी आपकी? h1 h2 0, यहाँ पे कोई भी एक मैट्रिक्स है x. तो इसकी आइगन वैल्यूज कैसे निकालोगे ब्लॉक की? आइगन वैल्यू ऑफ द h1, आइगन वैल्यू ऑफ द h2. आइगन वैल्यू ऑफ द h1 इज 1 and -1, आइगन वैल्यू ऑफ द h2 इज -1 plus 1. Is it okay? Now we can check about the geometric multiplicity. What is the geometric multiplicity of the 1? So 4 minus rank of this matrix. So -1, 1, 1, 0, 1, -1, 0, 1, 0, 0, -1, 1, 0, 0, 1, -1. ऐसे तो निकालते हो ना आप, n माइनस रैंक ऑफ a माइनस लैम्डा i. फाइन, सो निकालते हैं इसका, इसका रैंक निकालना बेसिकली आपको. सो अगर मैं इसको ऐड कर दूं, दैट्स 0, 0, 1, 1, और थर्ड एंड फोर्थ को भी ऐड कर दूं, इट्स 0, 0. फाइन, अब इन दोनों को ऐड कर देता हूं, दैट्स 0, इट्स 2, सो द रैंक विल बी माई 3. सो द ज्योमेट्रिक मल्टीप्लिसिटी ऑफ द आइगन वैल्यू 1 इज माई 1. सिमिलरली ज्योमेट्रिक मल्टीप्लिसिटी ऑफ द आइगन वैल्यू -1 भी आपका 1 ही आएगा. फाइन, अब इससे क्या मीनिंग हुआ आपका? अभी इससे क्या मीनिंग हुआ? एल्जेब्रिक मल्टीप्लिसिटी कितनी आ रही है आपकी? एल्जेब्रिक मल्टीप्लिसिटी ऑफ द आइगन वैल्यू 1 इज माई 2. देखिए 2 बार आ रहा है ना. एल्जेब्रिक मल्टीप्लिसिटी ऑफ द आइगन वैल्यू -1 इज माई 2, बट ज्योमेट्रिक मल्टीप्लिसिटी ऑफ द आइगन वैल्यू 1 इज माई 1. ज्योमेट्रिक मल्टीप्लिसिटी ऑफ द आइगन वैल्यू -1 इज ऑल्सो 1. और ज्योमेट्रिक मल्टीप्लिसिटी का मतलब क्या होता है? जॉर्डन ब्लॉक्स. फाइन, तो अब आप देखिए इसका मतलब इसकी आइगन वैल्यूज बनेंगे तो ऐसे ही ना आपके +1, यहाँ पे a और b कुछ भी हो सकता है. नाउ योर टारगेट इज टू फाइंड द वैल्यू ऑफ द a एंड b. चलिए ब्लॉक्स बना लेते हैं. फाइन, एक आइगन वैल्यू 1 का ब्लॉक बनेगा, एक आइगन वैल्यू -1 का ब्लॉक, और लेकिन मैट्रिक्स आपकी है 4x4, तो 4 आइगन वैल्यूज आपकी बनेगी. ज्योमेट्रिक मल्टीप्लिसिटी 1 है, तो इसका मतलब एक ही ब्लॉक बनेगा, उसका ऑर्डर कुछ भी हो सकता है. सो क्या क्या पॉसिबिलिटीज है? ये पॉसिबिलिटीज है कि -1 का सिर्फ एक ही ब्लॉक बने, एक सिंगल ब्लॉक, मतलब ये सिर्फ -1 का एक ब्लॉक बन गया, तो बिकॉज सॉरी -1 का एक ब्लॉक बन गया. फाइन, बिकॉज ये 4x4 है, तो बाकी का एक ही ब्लॉक होना चाहिए, तो वो ब्लॉक कैसा होगा? फाइन, ऐसा ही होगा. फाइन, ब्लॉक 3 का एक ब्लॉक बन जाएगा. तो इस केस में इसका ट्रेस कितना आया? इस केस में इसका ट्रेस कितना आ जाएगा? दैट इज माई 2, बट हमें ट्रेस कितना चाहिए? 0. तो इसका मतलब ऐसा पॉसिबल नहीं है कि एक ब्लॉक सिंगल -1 का एक बने आपकी. सेकेंड ऑप्शन क्या हो सकती है? -1 का 2 बना लेते हैं ब्लॉक भी. मतलब इसको मैं यहां पे लिखता हूं. मतलब क्या हुआ? ये आपका 4x4 है, तो -1 का एक ब्लॉक बनना है, लेकिन वो मैंने डबल ऑर्डर का बना लिया. तो अब बाकी दो कैसे बनेंगे? या तो वो दोनों सिंगल सिंगल हो सकते हैं, नहीं, एक ही ब्लॉक बनना है ना, तो वो कैसा होगा आपके पास? एक ही ब्लॉक बनेगा वो दूसरा. तो इसका मतलब इसका ट्रेस कितना आ गया? 0. तो इट मे बी पॉसिबल. थर्ड केस क्या हो सकता है कि -1 के मैं 3 ब्लॉक बना दूं, एक ब्लॉक बनाऊं लेकिन वो 3 का ऐसा बन जाएगा ना एक ब्लॉक. तो बाकी क्या रह जाएगा? मतलब -1, -1 का एक हो गया, और बाकी पीछे एक रह गया. इसका ट्रेस कितना हुआ? ट्रेस तो इसका -2 हुआ, लेकिन वो 0 नहीं है, तो ये केस भी कैंसिल हो गया. इसका मतलब इसकी एक ही फॉर्म बनेगी. वो फॉर्म कैसी फॉर्म होगी इस मैट्रिक्स की, जिसमें -1 का एक ऑर्डर होगा और 1 और 1 का एक होगा. फाइन, 0, 1, 0, बाकी सारे 0. और ये देखो आप, ये तो सेम मैट्रिक्स होगी ना, गिवन मैट्रिक्स. तो यस, दे आर ऑल्सो सिमिलर. सो A and C आर द राइट आंसर ऑफ द प्रॉब्लम. Okay, look at this another one. Capital T is my C7 to 7. That is a 7x7 matrix. Fine, it's a 7x7 matrix such that eigenvalues are my 2, 3, and 5. सो दिस पॉलिनोमियल इज, इसकी डिग्री कितनी बनी 6. सो बेसिकली ये आपकी एनिहिलेटिंग पॉलिनोमियल है. फाइन. देन विच ऑफ द फॉलोइंग स्टेटमेंट्स आर माय ट्रू. At least 4 linearly independent vectors. That means your target is to find the geometric multiplicity, or geometric multiplicity is also called the Jordan blocks. Fine. और dimension of the W is a 0, तो basically आपको nullity की dimension निकालनी है. Fine. Then kernel is itself defined for the nullity and the nilpotent. Very simple. सबसे पहले मिनिमल पॉलिनोमियल सोचते हैं क्या होगी इस मैट्रिक्स की भी. आइगन वैल्यू तो सेम रहेंगी ना आपकी, t-2, t-3, t-5. अब पावर कितनी होगी, वट एवर द पावर से a, b एंड c, बिकॉज वी ऑल नो मिनिमल पॉलिनोमियल जो है इसको डिवाइड होना चाहिए, तो द वैल्यू ऑफ द a इज ईदर 1 और 2. इससे ज्यादा तो नहीं जाएगा बिकॉज द पावर इज माई 2. b की वैल्यू कितनी होनी चाहिए, b इज ईदर 1 और 2. सिमिलरली c इज माई ईदर 1 और 2. इसका मतलब a की वैल्यू, b की वैल्यू और c की वैल्यू आपकी 1 और 2 के बीच में होनी चाहिए. इज इट ओके? तो 3 ब्लॉक, अगर a की वैल्यू आपकी मान लो 1 है तो आपका ब्लॉक क्या बन गया, ये बन जाएगा एक ब्लॉक. b की वैल्यू भी अगर आपकी 1 है, फाइन, c की वैल्यू भी आपकी 1 है मान लो, तो बट ये आपकी कितनी होनी चाहिए, 7x7 की होनी चाहिए. तो एक ब्लॉक तो आप कम से कम और बना ही सकते हो ना, आप एक ब्लॉक तो और बना सकते हो. मान लो आपने सारे 5 ले लिए, फाइन, तो कितने जॉर्डन ब्लॉक बन गए, 4. तो यहाँ पे एटलीस्ट 4 कह रहा है. फाइन. क्या ये पॉसिबल है कि इसके 3 ब्लॉक बन जाएं? 3 ब्लॉक कैसे बन सकते हैं, लेट्स थिंक अबाउट दैट. इसकी मैक्स वैल्यू 2 होगी, तो इसका 2 ब्लॉक आपने बना लिए. फाइन. 3 के भी आप ज्यादा से ज्यादा 2 बना सकते हो, 5 के भी आप ज्यादा से ज्यादा 2 बना सकते हो. तो इसका क्या 7x7 की मैट्रिक्स बन गई है. इसमें कितने बने, 6 बने ना. फिर भी एक आपको ब्लॉक फिर भी रह जाएगा, तो वो ब्लॉक आपका चाहे 2 लीजिए, चाहे 3 लीजिए, चाहे 5 लीजिए, तो मैक्सिमम, इसका मतलब मिनिमम कितने ब्लॉक बनेंगे आपके पास इसके अंदर, 4. सो दैट मीन्स एटलीस्ट 4. दैट्स अ राइट आंसर. फाइन. चलिए अब देखते हैं सेकेंड ऑप्शन. Second option is the dimension of the W. That means your target is to find nullity of the W. यही करना आपको. Your target is to find the nullity of the W. Now, how you can think about the nullity? I think it's a very simple. Why? Your target is to find the t minus 5i 0. Basically, it means they are talking about the generalized eigen space corresponding to the eigenvalue 5. फाइन. क्लियर. अब आप कितनी डायमेंशन, अगेन नलिटी है, नलिटी मीन ज्योमेट्रिक मल्टीप्लिसिटी की बात करनी है. ज्योमेट्रिक मल्टीप्लिसिटी इटसेल्फ इंप्लाइज दैट जॉर्डन ब्लॉक्स. फाइन. अब क्या इसके डायमेंशन 2 पॉसिबल हमेशा ही 5 से बड़े, 2 से बड़े होंगे. देखिए ये आपने एक बना लिया, ये आपने एक बना लिया. फाइन. यहां पे मैं एक डायमेंशन का एक ले लेता हूं 5. तो 7x7 बनाने के लिए कितना चाहिए, 2. बाकी मैं सारे 2 के ले लूं और सिंगल सिंगल 2 के. फाइन. तो इसका मतलब ये डायमेंशन आपको कितना मिल जाएगा, इसका भी 1 भी पॉसिबल है ना आपका, बट 1 इज नॉट ग्रेटर देन 2. सो दैट मीन्स दैट इज रॉन्ग ऑप्शन. फाइन. चलिए थर्ड ऑप्शन की बात करते हैं. क्लियर है ना, ये आपको डायमेंशन बोल रहे हैं कि 2 से ज्यादा होगा, लेकिन आप इसमें से जो मैंने ABC लिखा था, तो आप वैल्यू 1 ले लीजिए, तो एक ब्लॉक सिंगल बना लीजिए, बाकी सारे 2 के बना लीजिए आप. फाइन. सो इन दैट केस डायमेंशन मे बी लेस देन ऑफ द 2. चलिए थर्ड ऑप्शन की बात करते हैं. कर्नल ऑफ 2, कर्नल ऑफ द 2. ओके, पावर, कर्नल मीन्स डायमेंशन ऑफ द नलिटी. कर्नल इज द डायमेंशन ऑफ द नलिटी. अब आप यहां देखो, इसका जो भी मिनिमल पोलिनोमियल होगा उसकी t माइनस ऑफ 2i, मैक्सिमम पावर कितनी जाएगी इसकी, 2 से ज्यादा तो नहीं हो सकती, 3 तो कभी नहीं हो सकता बिकॉज इट कैन नेवर डिवाइड देम. इसका मतलब क्या हो गया, दैट मीन्स t माइनस ऑफ 2i रेज टू पावर 2 इज माई 0 फ्रॉम द इक्वेशन नंबर 1. फाइन. दैट implies t minus 2i raised to power k is 0 for all k which is greater than equal to 2. ये भी होगा बिकॉज अगर 2 0 है तो यू कैन पावर देम इट्स अगेन ए 0. तो यहाँ देखो आप पावर कितना है ये greater than of the 2, both the values are 0. Yes, it is the right answer. Fine. Now look at the last options. T minus 2i, t minus 3i is a nilpotent matrix. Fine. Okay, so आपके पास ये एक है t minus 2i raised to power 2, t minus 3i raised to power 2, t minus 5i raised to power 2. अब because the matrix is of 7 dimensions, so एक किसी एक की वैल्यू बढ़ा देते हैं, लेट्स से इसकी वैल्यू 3 कर देते हैं. सो इसका मतलब आपने एक मैट्रिक्स बना ली जिसकी सारी डायगोनल वैल्यूज क्या क्या होगी 2 and 2, 3 and 3, 5, 5 and 5. Fine. Then you can find the matrix of the t minus 2i. उसकी डायगोनल वैल्यूज क्या हो जाएंगी 0, 0, 1, 1, 3, 3, 3. फाइन. उसके बाद t माइनस 3i को करोगे तो कितना हो जाएगा ये -1, -1, 0, 0, 2, 2 and 2. और अगर आप इसको प्रोडक्ट करोगे तो डायगोनल मैट्रिक्स का प्रोडक्ट भी तो डायगोनल ही आएगा ना 0, 0, 0, 0, 6, 6 and 6. Clearly say which is not zero matrix. Why? Because diagonal में कहीं ना कहीं तो 6 मिल गया ना आपको. So but he said nilpotent operator. That is not true. So the right options are A and C are the right answer of the problem. चलिए look at this another one. V is a finite dimensional complex inner product space. V cross V, T star is adjoint. Which of the following statements are my true? Do you know what is a T into T star? T into T star is always a, yes, it is always the positive semi-definite matrix. Fine. If it is a positive semi-definite, अब matrix की बात हो गई है तो हम eigen value से solve कर सकते हैं इसे. Once is a positive semi-definite value, eigen values are always greater than equal to 0. Fine. Now it is given that the trace of the t of t star is 0. That means the sum of the eigen values are my 0 because the trace is nothing but the sum of the eigen values, and because the eigen values are positive and 0, this itself implies that each eigenvalues are my 0. And because it's a operator, so what does it means? That means t of t star is my 0. And once it's a 0, then you can define the inner product space t of t star, any vector v. This is my 0. I can write this number is t of t star of v. T star of v is 0. That it itself implies norm of t star v is my 0. Norm of t star v implies t star of v 0, and it itself implies that t is equal to 0. The first option is the correct option. Look at the second option. T of t star v is equal to 0. Again, this is a similar one. अगर ये 0 है आपके पास, that means t of v is 0. That implies t of v is equal to 0. Look at the third options. T is equal to t star. N is my greater than of 1. I can choose n is my 2. Then 2 raised to power, that is a t raised to power 4 of v is equal to 0. This is given. Okay. If this number is my 0, I can write this number is v of v is 0. Fine. I can also write this number is t square of v. T square of v is equal to 0. Fine. Because t and t star are same. Otherwise, you can write it as t square of v, t star square of v is equal to 0. But it is given that t and t star are same. That implies by the definition of the inner product space, it is my 0. अब ये अगर 0 है, I can write this number is tv and tv is my 0. If this number is 0, that it again implies that tv is equal to 0. The third option is the correct option. Look at the fourth options. T and t of t star is same as t star of t. N is equal to 2. I can choose n. Then it is given that t square of v is equal to 0. Again, it implies t of v is my 0. That implies t of v is equal to 0. All are my right answer of the problem. Okay, look at this another one. M2 is the space of the 2 cross 2 matrix. I hope student you can like and comment on the video as well. S is the vector space of the symmetric matrix. Fine. Then mapping is defined, which of the following statements are true, subjective and so on. एक टिप्स मैंने आपको पहले बताया था, if F is the mapping from A to B, fine, when it's said to be the onto, this is said to be the onto, this implies cardinality of A must be greater than or equal to cardinality of B. ये होना चाहिए ना आपके पास, but converse need not be true. Fine, need not true. फाइन. और कॉन्ट्रा पॉजिटिव क्या हो जाएगा, अगर कार्डिनलिटी ऑफ ए ग्रेटर देन कार्डिनलिटी बी नहीं है तो वो ऑन टू नहीं होगा. तो पहले कार्डिनलिटी देख लेते हैं. व्हाट इज द कार्डिनलिटी ऑफ द M2? 2 क्रॉस 2 है तो 4 हो गया. व्हाट इज द कार्डिनलिटी ऑफ द S? सो 2 क्रॉस 2 मैट्रिक्स है, इट्स ए सिमेट्रिक. इफ दिस नंबर इज माई ए तो ये भी ए हो जाएगा. फाइन. इफ दिस नंबर इज माई बी, बिकॉज देयर इज नो कंडीशन ऑन द ट्रेस, सो दिस इज माई सी. सो द अननोन नंबर्स आर माई 3. So this has a cardinality 4, this has 3, is satisfied. 4 and 3 satisfied, all are satisfied. Fine. चलिए, अगर इससे तो डिस्कार्ड नहीं हुआ, anyhow. Okay, then F is a mapping which are defined as X into X transpose. D of F A is defined as the derivative of the functions. So can you find the derivative of the functions? Fine. At the point A, so it is firstly A of X transpose plus X of A transpose. This is the derivative of this number. Then which of the following statements are my true? चल पीछे से स्टार्ट करते हैं. A is not invertible. कोई भी मैट्रिक्स लीजिए जो इन्वर्टिबल नहीं है. जीरो मैट्रिक्स ले ले. फाइन. व्हाट डज इट मीन्स? D of F कितना हो जाएगा? A जीरो है तो ये भी जीरो हो जाएगा. अगर जीरो है तो इसका रैंक ऑफ द जीरो मैट्रिक्स कितना होता है? जीरो. लेकिन ऑन टू होने के लिए आपको रैंक कितना चाहिए? इसके डायमेंशन के बराबर. रैंक कितना होना चाहिए आपका? 3, लेकिन वो नहीं आया. दैट मीन्स इट इज नॉट सब्जेक्टिव. सो द फोर्थ ऑप्शन इज द कैंसल ऑप्शन. फाइन. नाउ A is my invertible. You can choose any matrix invertible is say I. Fine. Then what is the matrix of the DF? A is equal to I, then it is a X transpose plus X, which is always be a symmetric matrix. For any matrix X, X belongs to the M2R. Fine. Then X plus X transpose is always symmetric matrix. So yes, it is my subjective map. Fine. लेकिन अगर आप इसको आइडेंटिटी मैट्रिक्स नहीं लेना चाहते, फाइन, देन आप क्या करिए, इस मैट्रिक्स ए को एक नई मैट्रिक्स से रिप्लेस कर देते हैं. लेट्स से इट इज माय H ऑफ X. फाइन. तो मैं अगर यहां पे फिल करता हूं, अगर मैं इस मैट्रिक्स को X को रिप्लेस, A इज ऑलरेडी गिवन टू यू, सो A इज इन्वर्टिबल, तो X को रिप्लेस कर देते हैं किसी मैट्रिक्स से. सो लेट्स से A ऑफ X. फाइन. अब मैं इन्वर्ट आई वाला केस छोड़ दे रहा हूं. फाइन. अगर मैं इस मैट्रिक्स X को A ऑफ H, where H is any matrix, where H is any matrix of the M2R, तो यहां पे फिल करा तो कितना बन गया? A ट्रांसपोज H ट्रांसपोज, फाइन, प्लस AH A ट्रांसपोज. तो यहां से आपने देखा A बाहर हो गया, H ट्रांसपोज प्लस H ऑफ द A ट्रांसपोज. फाइन. तो देखिए अगेन फिर से, दिस इज माय सिमेट्रिक मैट्रिक्स. फाइन. सो इफ A is my invertible, that means A into A inverse is my identity. Fine. So A is my invertible, A inverse is my invertible, so that means this is formulation of the symmetric matrix. So yes, third option is the correct option. Look at the first options. A of A transpose is my identity. That means A is my invertible matrix. Fine. अगर A invertible है by using the third options, the first option is also correct options. A and A, that's an invertible matrix, but he said need not be. That's a wrong option. A and C are the right answer of the problem. Dear students, I again suggested you can watch about my this playlist where you can find the complete solution all with the help of the shortcut tricks, either of the complex analysis, real analysis, and many more lectures in this playlist. You can subscribe my YouTube channel so that when I upload my next video, you can get the notifications. I hope you can enjoy this session too. You can share this video with your friends. You can like and comment on this video. Best of luck, students. Happy learning.